Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master, Refat Bari. Watch his videos to achieve your dreams.
Today what we're going to be looking at is really nice. We're looking at something called identity property. So let's get started, okay? So our do now is going to be pretty interesting today. I don't know how I'm going to set it up. Maybe I can set it up like this. Okay. Okay, let's break it into two parts. So our do now today has a couple of parts. Okay, and you're required to at least try to answer all of them. Okay. So here we're starting off with some basic questions. We're starting off with some basic questions. 1 times 5, 1 times 20, 1 times 100. Okay, so hopefully you know how to answer that. But now I'm going to give you a slightly more difficult question. Now try to listen what I'm going to say now.
Yeah, but one is to ask.
Let's say I have a magic matrix, okay?
I don't know.
Okay, this part is very important. Let's say I have a magic matrix that's just like the number 1. Any vector I multiply this matrix by, I'm going to get back the same vector. For example, if I multiply this magic matrix by 1 to 3, I still get back 1 to 3. If I multiply this magic matrix by even negative numbers work, -5, 3, -6. If I multiply the magic matrix by this vector, I'll still get back the same vector.
Do you know the dimensions?
Okay? That's up to you. Now, here's what I'm gonna say. This magic matrix is just like the number 1. 1 times any number is that number. This magic matrix times any number, any vector, is that vector. Now the main goal of today's do now, is for you to tell me, or at least try to guess, what this magic matrix can be. So I'm going to give you, I think I'll give you 5 choices. Hopefully 5 is enough.
1 by 1.
Okay, so
1 by 1, 1 by 3.
okay, so let me put in some numbers here.
1 by 3
0, 1, 0, 0, 0, 1, 1, 0, 0. Let's say I have 0, 0, 1, 0, 1, 0, 1, 0, 0. I can say maybe 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, or maybe I can 0, 0, 0, 0, 0, 0, 0, and 1, 0, 0, 0, 1, 0, 0, 0, 1. This is what I want you to do for this do now. Fill in these blanks and circle which one of these matrices you think is the magic matrix that will satisfy these equations. So go ahead, circle one of these and fill in the blanks. Good luck.
Can you help me?
So perhaps our students would like to come up to the board and attempt these problems.
So,
Can you do it using different color?
I'll give him the color red, if we even have red, or we can give him orange. Okay, good luck.
So, this is obviously 5. I'm going to leave the 1 times 20 blank for him, and the 1 times 100 is 100.
Why don't you fill in 1 times 20?
Oh, I'm going to leave that blank for Alex over here.
Oh.
I want him to participate as well.
Thank you.
And then the magic matrix.
Which one of
Let me
those
look at
is?
the choices.
I don't even understand what is that.
So the magic matrix is much like the number 1. Any vector you multiply it by, you get back the same vector.
Oh, you got it identity?
I will. Yeah.
But wouldn't it be 0, 1?
No.
Huh?
No. I think it's the last one.
I feel like it
Oh, the identity would be 1, 1, 1. No, I think it's the last one.
I can't decide.
Let's see how good you can guess.
So what are you trying to say?
So this is what I'm trying to say. 1 times any number is itself.
Okay.
This matrix times any vector is itself. Which one of these could be the magic matrix?
Oh, I see.
Good luck.
Okay.
Okay,
So the identity.
One of our
So-
cameras shut down.
Daisies.
Okay. Isaac, go with, yeah. Let me do it. So this is the identity, right? One is the identity, right?
Yeah.
Is that true?
Mm-hmm.
So for example, yeah, one is the identity, right?
Mhm.
So I think this is the identity. If you multiply this by this, you're still gonna get that.
Okay.
But think about 0, 0, 1, 0, 1, 0.
Only one of our students is correct. And it turns out that correct student is Alex. Okay, but why is he correct?
What?
Was it just by guessing? Most likely, but let's see how he got his answer, okay? I don't want this to be a guessing game. So what we're gonna do in the lesson is see if this magic is actually fact. Okay, lesson. So now we're moving on to the lesson. So our lesson.
Can you show me? I just guessed it. Can you show me how it works?
Yes, that's what we're gonna do in the lesson. Okay, so why don't I erase everything? So our lesson today is very important. So
Don't do that.
why don't we begin with 3 parts? Okay, 3 parts. So it's kind of like 3 parts. Okay. Okay. So what am I gonna do? Why don't I give you what I gave you in the do now? Alex correctly identified the identity matrix.
But I have no idea. I just guessed.
And that is why we'll expand on Alex's thinking right now.
I have
So-
no thinking.
Okay, I can't. That's unfortunate, I guess. But this is the matrix Alex chose. Okay.
I did not choose anything.
Oh, well, this is the matrix that was chosen, and let's multiply it by any vector really, but I want this to be a simple lesson, so I'll choose easy numbers. Okay, this is my claim. You can choose to believe it or not. This is gonna equal 1, 2, 3.
But you've been saying that like 10 times.
10
And
times.
instead of saying it, can you show me how?
Yes.
But what is 0, but what is
Okay.
0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0 give you the same output?
Let's see. We have learned to use columns and rows to multiply a matrix and a vector. Let's do that. How can I rewrite this in expanded column notation? How can I
1
rewrite it?
times 1, 0, 0.
Okay, so give it to me slowly. 1 times
1, 0, 0
1, 0, 0
plus
plus,
2 times
keep going. 2 times what?
2, 0, 0, 1, 0, 1, 0, 1, 0
0, 1, 0. Keep going.
plus
Plus
3 times
3 times
0, 0, 1.
0, 0, 0, 0, 1. Okay. Can we add these up now? Can we add these up? Yes, we can. A scalar?
Can you give us 1 second so we can try to
Yeah.
do it?
I'm gonna give you folks out there as 1 second as well, while you try to attempt the lesson. In the meantime, I'm gonna talk a little bit about why today is so important. Today is a very important day because recall that yesterday we were talking about elimination. Today we are laying the foundation of how we're gonna do elimination. So this is gonna be like the mechanics, okay?
Alright, we're done.
Okay, great. So can we multiply this scalar by this vector?
No.
Yes.
Oh, yeah.
So 1 times any vector is that vector. What about 2 times this vector? What do I
No,
get?
2. The middle one is 2.
Okay, the middle one will become,
Oh.
The last one is 3.
the last one will become 3.
But how that 1, 2, 3?
Well, can we add these 3 vectors?
Yes.
I get it.
And if
But
we
I don't.
do, what do I get if I add these 2 vectors?
1 plus 0 plus 0 is my calculator.
1. Right? 0 plus 2 plus 0, 2. 0 plus 0 plus 3, 3.
None of
And
you are the geniuses.
indeed-
I am.
Indeed, we see that we ended up with the same vector that we started with.
What do you call it? Identity matrix?
I will give this a name. It's called the identity matrix.
I just said that.
Okay.
And you pretended like you were saying something different.
Well, I have to formalize the notation.
But that's
So-
exactly what I said.
Well, yes. Okay, now, the identity matrix, a lot of people say it's important. But why is it so important? Now I'm gonna show you. Okay?
It's not important.
Okay. Well,
Yes, it is.
otherwise it wouldn't be so well known.
5 times 1 is 5. Some people would say 1 is identity. But who cares?
Everybody cares. You don't even know what a matrix is.
0, 1,
This is
0.
pure math, and it
zero,
may not be
zero,
useful or
1.
anything, but it's still beautiful.
Okay.
We can accept that.
Okay, are we ready for this? This is a very important moment.
It's
What?
1, 2, 3 again?
Again. Now I'm gonna make a change.
Sure, they be kidding. It's
Wait,
I will now
wait,
make
I
a.
have a question.
Okay.
Before, wouldn't the matrix 0, 0, 1, 0, 1, 0, 1, 0, 0 work as well?
Say it again.
Wouldn't the combination of 0, 0, 1, 0, 1, 0 and 1, 0, 0 work out?
No. Oh, that's good.
Why don't we try it out? You wanna try it out?
Oh, wow.
Because that was one of the choices.
I mean, the great thing about linear algebra is you don't have to speculate. You can why hypothesize when you can try?
Well, I said it don't work, so it don't
Okay.
work.
So let's see what
Not
we get.
everything you say is true.
Okay, let's see what we get.
1, 0, 0, 1.
Okay, 1, 0, 0, 1. Okay,
But you have a high capacity. You don't see?
keep going.
2, 0, 1, 0.
2, 0
1, 0.
plus what?
3 is 1, 0, 0.
3,
This is 2.
1, 0, 0.
So this is
What do we get? This
So
is
this
just the
Wow.
same.
1,
This becomes
2.
2, 2, 0.
very interesting, and
Oh,
this
this
becomes
becomes 3,
this
8,
becomes
2, 1.
3.
So this
And
is
what
3,
do we
2,
get?
1.
What do we get?
3,
3.
2, 1.
3, 2, 1. Isn't that strange?
Yeah.
Interesting. It's like we flipped the components.
So it doesn't work.
It doesn't work, but it's very interesting.
It doesn't work.
Yes, it doesn't work.
It
Okay.
doesn't work, but it's interesting. He said that, and
No,
we said
and
accept.
everything I say, he just ignored that.
That's right. Okay. So, but back to our
Because
original
not
question.
everything you say is true, or you God knows.
Okay. So, if I multiply this matrix by this vector, what should I get?
1, 2, 3.
1, 2, 3. Now I am about to make a very important change. Please observe
Yes,
carefully.
please. You speak over.
I have now just made a very important change, and I want you to predict what my new vector will be.
Easy.
Wait,
And because this is a prediction, I will write it in the color. Okay, I guess. Yes, please make your prediction. While
I have something.
oh yes, me too. So because this is a prediction,
4, 2.
I will write it in pink. So please,
So 1, 1, 0, 0.
Hey,
no,
can I have the this
predict
one?
what the.
I can't predict. I cannot put it in calculator.
Okay, just okay,
Let
just
me get a marker.
give me 3
Let
random
me-
numbers. What do you think it'll be?
Wait, let me try. Let me try. Let me try.
Okay, whatever.
I don't know how to put the matrix in the calculator.
Okay.
Plus
Do you know?
negative
No,
4,
it's
2,
not.
0, 0, 0.
So why don't we do it
Wait,
now?
wait,
Okay.
wait, wait, wait.
Let's-
It's
let's
negative
expand
3,
this.
2, 3.
Okay, let's expand.
Negative
Let's
3,
expand.
He said negative 3, 2, 3.
Oh, that's his prediction?
Yeah.
Okay. I'll write it in pink. Okay? because it's a prediction. What did he predict?
-3 to 3.
-3 to 3.
But I predict that's wrong.
Well,
Okay.
yeah, I predict you're wrong.
Let's see who's right. Are we ready? Are we ready?
I am semi-ready.
Are we ready? Okay.
I
What? How can I expand it?
1 100.
1 100. No.
1
Yeah, 1 100.
1.
Teacher, 1 0 0.
1 0 0.
Oh!
That's how you say it.
1 -2 0.
-2 0. Okay, let's keep going.
-2 1 0. Oh, 0 1 0.
0 1 0.
Did you've been doing it like that?
Mhm.
But oh,
Okay, let's keep going.
0 0 1.
No, 3 times.
Oh.
Now can we multiply scalar?
Yeah,
by
that's
this
the same
vector?
thing.
It'll give me the same thing, right?
You got 2.
Okay. Huh?
2 0 2 0.
0 to 0. Great.
And 0 0 1. 0 0
Excuse
3.
me, professor.
Yes.
I mean instructor.
Yes.
What's weird about this magic matrix thingy, Murdoch, is that if you turn it horizontally, if you do it row by row, it gives you the same answer.
No. We call this a symmetric matrix. I don't want to get into that now, but that is a very good observation.
Thank you.
Symmetric matrices are matrices that if you flip them over the diagonal, you'll get the same thing. Okay.
So 1
1
0
0
3.
I was
3.
wrong. You were
So
right.
what's the
Do
big
we
deal?
see something important happen?
No, I don't.
The 2
Do
is
we
gone.
see what?
Oh, 2 is gone.
The 2 is gone. It's replaced by a
0.
0.
Wait, I have a hypothesis.
hypothesis. Give me your hypothesis.
This -2 here will always cancel out the 2 here.
Good idea, but wrong reason. This is what happened. Are you ready to hear what happened?
I'm kind of ready.
First, this is what I will say. What row and column is this in?
Row 2,
This is in?
column 1.
Okay, so let's call this A. So this is in row 2, column 1, right?
Yeah.
What position is this in?
Row 2, column 1.
Row 2, column 1. So when I put this number in the second row and the first column, it happens to eliminate the entry in the second row and the first column. Okay, so this is very important. When I put this -2 here, it eliminates whatever number is in that position in the vector. Okay, so this is what happened. This -2 got multiplied by this 1 and then added to this 2. I will repeat that. This -2 got multiplied by this 1 and added to
Why?
this entry.
What?
That's right.
Well,
-2
I said
times
what
1.
and you said that's right.
Let me repeat that. -2 times 1 plus 2 will give us 0. Now, Alex asked us why. I think it's better if we address that. If you look carefully, when we expanded our notation, look what happened. This 1 paired up with this -2. Remember? We took... Okay, maybe I should write it again. Remember, we had this 1, we had 2, 0, 1, 0.
Your explanation is horrible.
0, 0, 1. Well, let's pay attention. Okay? I am claiming, this is my claim. This -2 got multiplied by this 1 and added to this 2.
Why?
What?
Then it's gonna be 0.
Right. Those are the mechanics of matrix multiplication. Look what happened. This 1 got paired up with this -2, right? See, it got paired up. We've been doing this forever, but see how it gets paired up with this -2?
Yeah.
And then it gets added to this 2.
Yeah.
So by the nature of matrix vector multiplication, when I put this -2 here, it gets multiplied by this 1 and added to this 2. So that's the beauty of matrix vector
I
multiplication.
don't see beauty.
That's why we have the third step. For those of you who are still confused why this is so important, I have
Do you
implemented
see beauty?
a third and final step.
Do you see beauty?
Okay, now, this is an extremely important step.
You've been saying it.
Yeah. So, I want you to notice
Extremely important for what reason?
well, let's see. I want you to notice what just happened. Do we see a difference between these two vectors?
1, 2, 3, 1, 2, 0. Yeah.
This is a 0 and
Someone
this is a...
someone changed something to a 3/2.
Right, so this is 3, this is 0. Now my question is this. What matrix do I have to multiply this vector by to get 1, 2, 0?
Hold on,
What matrix do I have to multiply this vector
Let
by?
me hypothesize.
Please hypothesize in pink. Please hypothesize in pink.
Yeah.
Here, pink.
That's
Pink.
pink.
Please hypothesize in pink.
Okay, so
1, 2, 3.
No. 0, 1, 0, and then 3/2, 0, 1.
Okay, so the student here hypothesizes
Really?
if I multiply this matrix by this vector, I will get this vector.
Really?
However, his answer is in fact incorrect.
Yeah, very.
I want you to understand why it's incorrect.
But is it close to correct?
No, without even doing multiplication, how do I know it's incorrect? Let me show you how. What position is this in?
This column 1, row 3.
Row 3, column 1, right?
Yes.
What position is the 3 in?
Row 3, column 1.
Row 3, column 1.
Oh, that's
Okay.
good.
Okay, so let's understand what's happening. This minus 3/2 is getting multiplied by this 1 and added to this 3. If I multiply minus 3/2 by 1 and add 3, do I get 0? No.
I re-hypothesized.
Our student has rehypothesized and unfortunately he has made the situation worse.
This teacher is not good.
Understand that the coordinates must be same. What are the coordinates of this
No,
entry?
just kidding. I re-hypothesized
Final one.
1 more time. And then change this to -3/2.
Okay, so third time's the charm, and unfortunately it didn't occur this time. So let me show you the answer.
It's not your fault. The teacher is horrible.
Okay, this is what I know. I know for a fact if I multiply this identity matrix by this vector, I will get back the same vector. Right? But now I'm going to make a little change.
It's lying. You're gonna make a big change.
That's it.
Oh, I knew that. You gotta be kidding me.
No.
I knew that. -3 is equal to 0. Everybody knows that.
No, that's not what's happening. Let me show you what's happening. Ready?
This is cheating.
Let's expand this and
Okay.
understand what's happening.
But
What is it?
-3 plus 3 is 0. So what is the big deal here?
That's not what we are doing.
Oh no.
Okay? So 1 times this vector plus what? Plus
1, 0, 3. But you have to give me time.
0, 1, 0.
1, 0. And then 0. 0. Where did you get 3 from?
Oh, no.
Oh, 3. Okay.
I'm just saying this is the
0,
final
0, 1.
answer.
0, 0, 1.
Okay,
Alright,
let's see if it
so
gives
you
us.
change nothing.
Okay, nothing.
You change the middle one.
Middle one.
And you change the last one.
Change the last one.
So you have 1, 2, 0.
So.
But
this
it's the same thing. I knew that all along.
No, see?
Oh, probably because I'm smart and genius.
No, let's try to understand what's happening here, okay? Let's try to understand what's happening. This entry is in the row 3, column 1. So, it's in row 3, column 1, right? I'm going to take this entry, multiply it by whatever the first entry in our vector is, and add it to this. So, -3 times 1 plus 3.
You said the middle one. You said it to middle one. Now you say add it to the last one.
Well, our
Contradiction.
situation has changed. Previously, the location of the coordinate was row 2, column 1. Now it's row 3, column 1. So we need to adjust and adapt accordingly.
But -2 +2 is 0. -3, +3, 0. What a hard.
Well, we're gonna come up with many more examples in future lives so that
Probably
we
just
can,
probably because I'm just.
we can understand this better.
Right?
Hopefully our exit flip will help you at least understand the concept a little bit better.
Probably just because
I'm just gonna do the exit flip before you write it.
Okay, exit flip. Exit flip.
Can you help me with exit flip?
Okay. So our exit flip is
You're
this.
trying to use mine.
Okay.
Not gonna even work because I can do everything wrong.
Actually, I don't know what the exit flip is.
You're just making this on the go.
Okay, so it will be a multiple choice exit flip, and you will have a few selections to choose from. All you have to do is circle your answer.
Who murdered the 9?
I'm good in circling the answer
Who
so-
murdered the 9?
because I can just guess it, right?
What if you guess it wrong?
I
There's
mean,
there's a 4 in 5 chance that you get it wrong, and a 1 in 5 chance that you get
I mean,
it wrong.
what is the odd of getting it wrong? Nothing.
80%. That's the majority.
But so what? This guy gonna give me F anyway.
That's right.
Oh my god. That's just sad.
Okay, so are we ready for this moment? I hope so. So please select. This is the question.
So like
I am gonna multiply this vector by a magic matrix, and it'll give me this vector. I want you to select which one of these could be
I
the
already
magic
know.
matrices.
hypothesis? Please say.
Perhaps our other student
Rodriguez. My name is Mr. Rodriguez.
Perhaps Mr. Rodriguez would like to make a better selection.
And my first name is Alex.
Perhaps Alex would like to make a better selection.
Say my whole name.
Perhaps Mr. Rodriguez would like to take a better selection.
Oh my god. This is a rocket with the dates.
This
That's a
teacher
new
is
teacher
not
or
good.
what?
Wow.
The teacher changes the answer.
So, this is unfortunate because
Oh wait.
okay, I'll give you the answer. Out of the 4 choices, our students chose 2 answers. Neither of them were correct. In fact, none of these answers are correct. The correct answer has a -3.
But it was negative there before.
Well,
You erased that to sabotage this guy.
okay. So, well, our student originally made the correct response. I just wanted to see if you could adapt to the new responses. So I want to congratulate
This teacher
our
is.
old student. I did not intend to sabotage
That's why
you.
he gave me.
I just wanted to teach you a lesson.
I got the
Okay.
right
He's
answer.
sabotaging all of us.
But
Give him
at the end of the
and
day,
tell the principal, get him fired.
please understand what's happening here. See this -3? It's getting multiplied with
By
the
the
3
3
over
and
here,
that
and
and
it's
the
getting added to this 9.
blah blah blah.
So you see the process, right?
I don't.
-3.
Oh
gets
yeah,
multiplied with the 3,
I see.
Add it to the 9.
Oh my God.
We
this
get the
is
0.
smart.
Okay? So our students have made the correct choices this
Can I
time.
see you after school?
Yes. So thank you for watching.
No, I have to ask you a few questions. Why you give me F?
Yes.
What do you mean yes?
Thank you.
This guy,
This is awkward.
this guy is not good.
Okay, we want to have to.
Subscribe to Bari Science Lab to fall in love with math and science, especially programs